Session 5.4. For this session, we talk about multiple DC sources connected in series. As shown here, we have n voltage sources connected in series. They are V1, V2, V3, and all the way to Vn. A key observation here is all these voltage sources are in the same directions, which means the positive terminal for every source is on the left-hand side, and the negative terminal for every source is on the right-hand side. We are measuring from A, the positive terminal, A towards B. The direction of the source is very important. So here, the total voltage of the entire voltage source system is Vt equals to V1 plus V2 plus V3 and plus all the way up to Vn. So that is the way to find the total voltage for this system. Now let's look at another scenario. Just by randomly pick one voltage source, such as V2. I just arbitrarily select a source, and then pick that one, flip it. So far, only V2 face the opposite direction comparing to other sources. The question is, what is the total voltage source for the system now? Since we flip V2, in other words, V2 is the only one opposite to other sources, and we are measuring from A, the positive terminal, A towards B. So A is the starting point, B is the ending point. The total voltage of the system, Vt, equals to positive V1 subtract V2, since it's in the opposite direction, plus V3 plus all the way and then to Vn. So this is the expression for this circuit. Let's work on this example. We have three sources connecting in series, and the sources together provide a voltage to the resistor R, that is 1 kilo ohm. We want to know what's the current in this system. So put the circuit to the side. First, find the total voltage for this system. In other words, if you replace these three DC sources by only one source, what's the value of that one source? We know they all face upward, which means the positive terminal is above, and then below for each source is the negative terminal. So the total source Vs is the sum of all three sources. 1.5 volt plus 5.0 volt plus 3.3 volt. That is 9.8 volt. To find the current, we can use the Ohm's law's current formula, Vs over R. And substitute the values. Vs we calculated already is 9.8 volt, and R is 1 kilo ohm. So after entering the numbers into a calculator, I got 0.0098 amp, and change the numbers to engineering notation by moving the decimal point to the right 3 times, and then reduce the prefix by 1000. So it's 9.8 milliamp.